And this is a detail I'm excited to try on this. I've done it with dimple mat in the past underneath, but basically we're down in the basement. The walls are insulated now. The floor will be. This is the concrete footing. This is an interior footing. This is an exterior footing. Step back and you see we're at like a corner of the house, interior corner. So you can see back here the concrete wall, and that's a pretty imperfect surface. It's got, you know, roughness, and when this 2-inch foam board is pushed up against it, it's going to have a drainage path for bulk water, and the water is going to come from either a crack or condensation or anything. There's going to be water in the foundation. It's just you're not going to stop the hydraulic pressure from coming through. So in order to mitigate the risk here, there's a cedar breather, which is made by Benjamin Obdyke, and it's got a 200 pounds per square foot rating, so it's no issue with pouring a slab over the top of this. It's not going to crush. And what that does is hold this 2-inch foam out just a little bit when that sneaks in there. And then you can see it also holds it up a little bit. So the water is going to run down the back side of this, hit the footing, come out, and drain down in the stone, which is then connected to a perimeter drain as well as an interior drain. And there's 10 to 12 inches of 1.5-inch stone in here, so there's a huge reservoir that will drain out. But with this, you can kind of see on the corner here too, I'm going to tuck it down and leave just a little bit of a gap right here, and that water is going to run out right across and go underneath here into the drain. And then on top of this will be a 10 mil plastic that rolls up all the way up this, and then the 4-inch concrete slab will sit right above it. And that's going to make the interior 4-inch concrete slab in the basement within the conditioned space. So it'll be within the water boundary, because the water boundary will be down at that plastic, will be down on the opposite side of this 2-inch foam, so on the underside as it goes up and over. And then there's a thermal boundary with the foam. There's also air control layer by having that plastic roll up, and then it's going to connect all the way to the top, and it will be continuous from the floor up the wall all the way up to the sill. And then it'll also be a vapor boundary, because that plastic isn't going to allow any water vapor to transmit in. So once that 4-inch slab is here, there'll be a 2x4 wall above it, and that'll all be within the conditioned space as well, so there won't be any chance of moisture, mold. Up top, this is it's all insulated, but I don't have the plastic in yet. Just got to finish this section down here. What we're going to do today. I'm still going to cut the top of this foam off, and then there's going to be that plastic that's going to run up this wall all the way from the bottom, run up the wall, over this, and then turn up onto that 2x sill. So that'll give it some continuity all the way around and completely separate this concrete from the building. So there won't be any water, air, vapor, or heat flow from here inside the building. It will be completely broken by all 4 control layers. And over here with the garage door, and cut this down, and that slab is going to run out, and there will be, this will be the only point where there's a thermal bridge. It'll be a 4-inch by 3-foot concrete that goes out, There's really no way to get around that easily because the door needs to sit on something solid. But that'll be cut out there, concrete will run over, and then the stairs will start down.